Hello viewers, welcome to another video. All right, so in this video we have on the board a question about electromagnetism. Okay, so this is a question under what we call diffraction. Okay, diffraction. Diffraction is a phenomenon of light bending around a corner, or light passing through a small gap whose wavelength, whose dimension is exactly one wavelength. That's diffraction. So just like what we have here, the incident beam passes through a small opening or gap and then emerges at the other end, it diffracts. You understand? They spread out, the light beam spread out. Okay, so we have here an astronomer uses a spectrometer and diffraction grating to view a hydrogen emission spectrum from a star. Okay, the light is incident normally on the grating. Okay, so we have now what we have here is first order. Now, first order. So we have first order spectrum. Okay, so first order diffraction maxima are observed at angles of this, and this. This is 12.5, this is 14, and this is 19.0 degrees to the direction of the incident light as shown in the figure above. So we have two of the wavelengths are 4.33 multiplied by 10 raised to the power of minus 7 meters, and also 4.84 multiplied by 10 raised to the power of minus 7 meters. So we want to calculate the wavelength of the third line. You can see we have three lines here. So we're going to calculate the wavelength of the third line. And don't forget that we are using first order. So the first thing is, now, what formula are we going to use in order for us to calculate the wavelength? All right, that's the third line wavelength. Now, to calculate the third line wavelength, there is an equation. There's an equation which can be modeled. An equation which is modeled for questions like this. Now, and we call it the diffraction grating equation. All right, so diffraction grating equation. Now, when we talk about the diffraction grating equation, all right, the diffraction grating equation is D, which is the diffraction, the grating spacing. The grating spacing. This is the grating. All right. So sine angle of diffraction equals to the order multiplied by what? The wavelength. Now don't forget, D is the what? The grating. All right. The grating spacing. The unit of that will be what? Meters. Then we also have the what? The diffraction angle. We have the diffraction angle. That's theta. All right. Then M is the what? Is the order. Then we also have this guy to be the what? To be the wavelength. All right. So now, one thing is missing here, and what is missing here is D. Now we have the angle of diffraction. We know the order is what? The first order. So M will be what? 1. So it means that M would be what? 1. So M is 1. So we are giving the two wavelengths are this wavelength and this wavelength. So we are giving the two wavelengths. So we want to find out the value for the third wavelength. All right, the wavelength of the third line. So let's first calculate D1 for wavelength. That's wavelength 1, which is 4.33 times 10 raised to the power of minus 7. And also D2 for wavelength 2, which is 4.84 times 10 raised to the power of what? Minus 7 meters. All right, so in this case, we can rearrange, the equation, rearrange the equation. That is what I mean, rearrange the equation. That is, we can now what? We want to express D in terms of every other parameter. So we know that D would be equals to M, that's the order, multiplied by the wavelength, okay, divided by what? Sine angle of grating. Okay, the grating angle. All right, so now we know that the first wavelength is given to be 4.33 times 10 raised to the power of minus 7 meters. Okay, M is the order. So the first angle, that is the grating angle. We are giving this grating angle to be 12.0 12.5. That's the grating angle. So we're going to what? Now we're going to calculate the value of D. In this case, we calculate the value of D. So D1, okay, which is for the first wavelength, we're going to use M multiplied by, okay, we have 4.33 multiplied by 10 raised to the power of minus 7. Then sine 12.5, that is 12.5. So let's get the value for sine 12.5. Sine 12.5, that would be 0.212.5. That would be 0.2164. 0.2164. So this is 4.33 multiplied by 10 raised to the power of minus 7. Then we have 0.2164. So let's get the value for when we divide 4.33 by 0.2164. Okay, that would be 20.009, and that will be 20.01 multiplied by 10 raised to the power of minus 7 meters. Okay, so that's D1 for wavelength 1. Okay, now for lambda 2, that's wavelength 2. Okay, this one is for wavelength 1. Okay, we have for wavelength 1, okay, wavelength 1, and that's what we have. So for wavelength 1, we know that D2 would be M multiplied by lambda 2, then divided by sine of the second grating angle. All right, so this will be 1, because we have here, we're dealing with what? First order spectrum. So 1 multiplied by the wavelength, the second wavelength is 4.84. 4.84 multiplied by 10 raised to the power of minus 7. Then sine, now this angle, the angle is what? 14. So we have 14. Now let's get the value of sine 14. Now sine 14 degrees, that will be 0.2419. 0.2419. So that will be 4.84 multiplied by 10 raised to the power of minus 7 divided by 0.2419. Okay, so what is 4.84? 4.84 divided by 0.2419. Okay, so that would be 20.009, and that means we also have 2.009, which will be 2.01. Sorry, 20.01. Now we multiply by 10 raised to the power of what? Minus 7. Then the unit is what? Meters. So we now have the what? The grating spacing for wavelength 1, okay, and the grating spacing for wavelength what? 2. So to calculate the grating spacing for wavelength 3, remember we want to calculate wavelength 3. So for wavelength 3, okay, for lambda 3, we know that lambda 3, when we rearrange this equation, lambda 3 will be D3, which is the spacing grating for, you know, the third line. Okay, let me use the third line. So this is the spacing grating for the first line, okay, and this is the spacing grating for the second line, that's D2. So now we want to what? We have our D3, which is the spacing grating for the what? For the third line. So this multiplied by, we have it multiplied by sine of the third grating angle. Then we divide that by what? M lambda. M rather, that's M. Now, what is D3? Now, to calculate D3, D3 is the average between the spacing grating of the first line and the spacing grating of the second line. So D3, okay, is the average between D1 and D2, okay. So that would be 20.01 plus 20.01. Then we multiply that by 10 raised to the power of what? Negative 7. Then we divide it by what? 2. So when we add this up, okay, we're going to have 40.02, which when we divide it by 2, we're going to have 20.01. So this will be 20.01 multiplied by 10 raised to the power of what? Minus 7 meters, which is the unit of the spacing grating. All right, so we're going to plug in the value of D3 into this equation so that we can obtain the value for the what? The wavelength of the third line. So this value 20.01 multiplied by 10 raised to the power of minus 7. Okay, then sine the third angle. Remember, the third angle, that is grating angle, is the what? 19.0 degrees. That's 19.0 degrees. So we are multiplying this by what? 19 or 19.0 degrees, which will now divide by what? The order. So the order is what? 1. Okay, so let's get the value for sine 19. Okay, sine 19 is 0.32556. 0.3256. So we have 20.01 times 10 raised to the power of minus 7. Then we have 0.3256. So when we multiply 0.3256, okay, when we multiply by 20.01, okay, then we're going to have 6.515. 6.515. So the wavelength of the third line will now be 6.515 multiplied by 10 raised to the power of minus 7 meters. This is the wavelength degrees, which will now divide by what? The order. So the order is what? 1. Okay, so let's get the value for sine 19. Okay, sine 19 is 0.32556. 0.3256. So we have 20.01 times 10 raised to the power of minus 7. Then we have 0.3256. So when we multiply 0.3256, okay, when we multiply by 20.01, okay, then we're going to have 6.515. 6.515. So the wavelength of the third line will now be 6.515 multiplied by 10 raised to the power of minus 7 meters. This is the wavelength of the third line. Remember, the noblest pleasure is the joy of understanding. I'll see you in the next video. Thank you.